Hey students, this is lesson 12-2. We're going to learn how to use congruent chords, arcs, and central angles, and how to use perpendicular bisectors to chords. Go ahead and do the review, and I'll check back with you. All right, so there's a couple of theorems we're going to use here. Theorem 12-4 says within a circle or in congruent circles, congruent central angles have congruent arcs. So if angle AOB is congruent to angle COD, then arc AB is congruent to CD. I'll let you go ahead and read the rest of them and try and fill in your answers. Okay, so let's use those theorems. It says, what can we conclude in this diagram, given that BT is congruent to RP? So we have those two are congruent. And just thinking about this, so I guess we have to assume that D is the center of this. And so if that's true, then we know that RD is congruent to PD. And also congruent to dV and dt, because they're all a radius. And so we have, by side, 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 we have two congruent triangles. And the other thing we can conclude here is that this arc here is congruent to this arc here because they are made from two congruent chords. So I'm just going to write that out for you. So here's the statements and the reason for that. You could do it other ways too. I was thinking you could show that those two angles are the same because they're vertical angles. And so you have isosceles triangles also. That would be another way to prove they're congruent, or side angle side is another way. All right, I'll let you try that. Fill in the reason here. Check back with your answers. All right, a couple more theorems we're going to use here. Theorem 12-7 and its converse, 12-8, 12-9, 12-10. This has to do with if you have two chords, how to tell if they're congruent or not. Go ahead and read through these and try to fill in the answers as you go. All right, so let's apply some of those theorems. So given an arc like the one below, how can you find the center? Let's try this problem first. Problem 2. What is the value of A in the circle? Well, according to theorem 12-7, since we have a perpendicular line drawn to both of these, that arc there, or that chord there and that chord there must be congruent because these distances are the same. So we're going to say that okay, so by theorem 12-7, we can say that A plus 6 is equal to 12. And since A plus 6 is equal to 12, then A must equal 6. All right, I'll let you try that. Okay, given an arc like the one below, how can you find the center of a circle that contains the arc? All right, we're going to use the idea that if we find the perpendicular bisector of an arc, that will be a diameter of the circle. So if I find two perpendicular bisectors of two arcs, those will both be diameters, and where they intersect will be the center, because every diameter goes through the center. So, and I'm not going to use a compass or a protractor here. I'll just demonstrate drawing some lines in. So let's say I'll just draw one chord here, and I'll draw one chord here, and these are just random chords. So now, if I draw and I'll use a dotted line for this, if I draw the perpendicular bisector to each of those, and so I have to make sure that this distance right here is the same as this distance, and that this is a perpendicular line. And if I do one more of those, and again making sure that I have equal distances here and here, and that this is a 90-degree angle, then those are both those lines will be part of the diameter of that circle. So where those cross, since all diameters cross in the center of the circle, will be the center of this circle. And so if you took a compass now and drew a circle around that center, you'd have the whole circle. All right, I'll let you try that. All right, finding measures in a circle. What is the missing length to the nearest tenth? So this first one, since this is a perpendicular line right here, we know from these theorems that these two lines are going to be congruent. So we know this length is 6, and since this is also a right angle, that's a right triangle, and we can use Pythagorean's theorem. So x squared is equal to 5 squared plus 6 squared. And 5 squared plus 6 squared is 61. So x is equal to the square root of 61, which is about 7.8 to the nearest tenth. All right, on this one, we have a similar situation, only a little bit different. We know that this segment is congruent to this segment, so that tells us that this is a right angle. And we also know that this is a radius, and so is this, so they should be the same length, so that length is 9. So in this one, we're going to say 9 squared is equal to x squared plus 5 squared. And so 81 is equal to x squared plus 25. And subtract 25 from both sides, and we get 56 is equal to x squared. So x is the square root of 56, which is about 7.5. All right. I'll let you try that. And the lesson check. Circle the names of figures that have two ends. Is a radius a chord? Is it a diameter? Is a diameter a chord? Explain your answers. All right, the names of figures that have two endpoints on the circle, that would be a chord and a diameter. And underline the name of figures that have one endpoint, that would be a radius. Is a radius a chord? No. Is a diameter a chord? Yes. Anything that has two endpoints on the circle is a chord. All right, that's it. I'll see you tomorrow.